Hello, and welcome to another episode of A Junior, a Senior, and I, which is still a lie. Again, I'm joined by two very senior people in Rob and Tim to discuss object-oriented programming. But before we do that, let's meet our guests. Tim, could you introduce yourself in 3 sentences or less, please?
Sure. I'm a longtime software developer and coach, consultant, whatever, moving through the system for many years. I got involved with object-oriented design when I was a member of Object Mentor. So this would have been in the 90s. Actually, I was involved first and they hired me. And I've worked a number of different ways, object-oriented, imperative, some functional, through the years. So I am a maybe multidisciplinary kind of person.
Great. Thank you very much. What about you, Rob?
Yes, so again, long-standing in the industry. Maybe my credentials aren't as strong as Tim's, but so I'm a senior developer and director of software development for Europe, Middle East, and Africa for ThoughtBot, a design and development consultancy. Been writing web programs professionally for 19 years and unprofessionally for even longer. Excited to talk about object-oriented programming.
Nice. Thanks. I'm going to assume that people listening know what object-oriented programming is. So let's not do the what it is. But when it appeared, what problem was it trying to solve? Or what problem does object-oriented programming solve?
So the original statement by Alan Kay, who is, all things object-oriented have to go back to Alan Kay. His idea was that it's a way of organizing your work. And he used a cellular kind of biological metaphor. He said that cells are things that are contained, they have their own internal workings, and they communicate by sending signals to other cells. So ultimately, the system design is how the different cells communicate. You have nerve endings that communicate through the spine to the brain, back out, and then chemicals are produced. Chemical signals hit parts of your body. Suddenly you have adrenaline and your strength is increased, and so is your stress. So it's a kind of a thing. It's a way of organizing your work originally. And in Smalltalk, I think that's a good description. It describes the way people use AI for the past 20 years rather poorly because they've gone pretty far off the mark.
I think it's interesting. Everything seems to come back to Smalltalk at some point. I keep reading more and more stuff about it, and it's something that you want to dive into. That seems to be like the pure point for the birth of object-oriented programming at some point.
And it is, by the way, the birth of the term. Alan Kay came up with the phrase object-oriented to describe how Smalltalk works.
So Smalltalk was there before object-oriented was thought of then?
Oh, yeah. Smalltalk came first. Yeah, it's based on ideas they pulled from other places, simulation, and, every great idea is a synthesis of other good ideas. So it comes from simulation and other places.
I'm going to try to get an opinion here. Now that we know a bit more of what it is and what it serves for, how purists are you about OOP? Like when you write code in an OOP context, how purist are you about that? Are you mixing it things from other paradigms, or are you trying to stay like, okay, it's just cells sending messages to other cells?
So I write most of my code pretty much all my code in Ruby. So in Ruby, everything is an object. That's kind of part of its definition. But in Ruby, there are certain things to it that are functional. So a lot of the stuff where you iterate over things, or anywhere where there's a block, that becomes considered functional to some extent. But when it comes but I always try to design towards using objects, using my tests drive me to point somewhere that a test is getting complex or something that indicates that there's a missing concept that we haven't thought of in here. And that's usually another class or another object that we need to introduce. And I will always try and find the right noun or the right verb. And that's kind of the naming things is the hard part. And I do get frustrated. There's a kind of a trend in the Rails world at the moment to have these service objects that just have a call method on them, and they're really non-descriptive. And it's like there is a prettier name that could exist here. And so I think that's, as being a Rubyist, I choose Ruby because I think it reads nicely. It's pretty to look at. And so I think we're doing a disservice by not using the right nouns and verbs to kind of express ourselves in our code. So I will try and be purist, which I'm interested to know what you think purist means as well.
So, by the way, I'm writing a little mini book on how to name objects, classes, functions, and things. It's a big expansion off of the chapter we wrote in Clean Code. So I wrote chapter 2 in that book, which is, by the way, also second edition Clean Code is out, I think, last month or so. But yeah, watch for that. Maybe it'll help a little bit with the naming. I'm trying to help people understand how it's done rather than telling them what to do with rules. So it's the same approach I took with the Vim book. So if you saw that, you'll know. So anyway, yeah, I think even when I was, entered into OO, it was through the gate of C++ at the time. And inside every object, it gets non-object-y, right? I mean, at some point you get down to strings and integers and imperative statements. And I'm a Python programmer by choice. So Rob and I are in the quarrelsome cousins area. So we're so much alike. We share so much, and yet sometimes we like to argue about the differences. By the way, Ruby's array methods are better, just for the record. Python has much to recommend it, but the .each and those are better. So, eventually you get down to that. And of course, my Python code is going to be full of list comprehensions and generators because that's, Python is a hybrid-y kind of language. But my abstractions tend to fall pretty much along domain term lines, and they tend to be objects, and they are sending messages. Ruby and Python are not quite exactly to the extreme that Smalltalk is with messaging, but it's not that far off. It still looks like function calls. So I'd say that we're fairly tight probably on that. I do like to use domain abstractions, and I'm also not a huge fan of putting functors, which are classes that act like functions, all over the top of everything either. And certainly the time I've spent in Java, it seems like they built the frameworks to avoid OO to the best possible extent. So you end up with a data object that holds all the state, and then you have a bunch of service objects that hold all the functions, and they don't have bounded contexts. They don't usually build their own types for things other than just, that kind of an arrangement. So remember that to the middle, or to either end, right, of a spectrum, the middle looks closer to the other.
I'm not sure I got that.
So, just draw a line on the ground, put a dot in the middle, and walk to one end and look. And that dot, you swear, is closer to the other end. And you'll find out that's the same thing with arguments and political positions. And, what does a purist look like? Well, you look like a purist to me. Well, that will be true if I'm very non-purist. But if I'm a very strong purist, I look at the same person. It's like, oh, you are so contaminated by non-purist ideas. So the middle always looks further the opposite end. I can't say how middle I am, but I do know OO and I do use it. But I don't throw a fit if I see imperative statements or functional statements in my code.
I was going to say, it's interesting, like when you think about purists, because I'm thinking about all these different rules I've heard over the years in terms of like, you have to have like a separate read or write methods. It can either, like, it shouldn't do both, or it shouldn't, like a pure message shouldn't return a value maybe, or like there's all these different kind of opinions on what your methods or messages should and shouldn't do. But it's interesting. I think for me, it's all about, does your code tell the story that you want it to in the nicest possible way? I think it's the objective.
Yeah, there's a lot of different ways to express your ideas, and OO is among those. Yeah, functional programming, you can talk about purity because they have pure functions and no side effects, and something is more pure, less pure, by clear rules. It operates only on its parameters. It returns a new object. There's no nothing's mutable. With OO, I don't know how you can describe purity, really.
No, sure, and it's more. I agree with you that it's more of a range, but there are some, let's call it principles, although it's not even that shape how you code, right? Like, I do want an object that is a self-contained unit that sends messages, that does one thing, etc., 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 that all put together paint an object-oriented picture, right? And even in a language that has classes, that has objects, you can have code that has classes, that has objects, but it's not actually object-oriented, right? So it was more, and picking up the thread that you both launched with the service objects, which is the name in the Ruby community, Rob, and the functors, which I'm guessing is the name in the Python community team.
Or in the C++ community.
In the C++ community. Those exist in an OOP world, but are not truly OOP, right? So it was more getting those shades of gray.
So, some people would say, well, part of this would be the whole tell, don't ask, right? So thinking about the different principles, and I was around early with the solid principles before we called them solid. That came later, which I think was nice because then people could remember them. There's along with that, there's the command query separation and a bunch of other principles at work. I like the idea, by the way, of tell, don't ask. I like the idea that I have an email thing and I say send this message and it does. Or if it can't, it throws an exception that it can't. Now, when I say exceptions, the Java people are going to go crazy. I know they do because they have their own meaning. In Python, it's very normal. An exception is just how you say I can't do that. It's not a bizarre the world is ending and there's nothing anybody can do about it situation. It's just like that's how you say no. So a lot of times you get functions that don't return anything, or they return a record, of things, or they just throw an exception. So I don't remember that being so much a Ruby behavior, but I think I actually did encounter tell, don't ask first in a Ruby context.
I think one of the things I see people with their learning object-oriented design is that kind of tell, don't ask, because there'll be something like, does this user have an email address? Okay, send the email, send email or something. Whereas instead of asking the user checking the state of the user, you should just tell it to do it. And it's up to that class to know whether it can do it or not. The other object shouldn't care. It should just go, do it. I trust you to do it. And I think a lot of object-oriented design is about that trust, because you have to trust that the object's going to do what you want to do. And some people say, oh, there's too many small objects. How am I supposed to know what they do? And you go, well, you look at the methods and assume that they do what you want it to do and go from there.
It's written on the tin.
Yeah. So there's an interesting point in object-oriented programming, object-oriented design about how many classes is enough, because you can have too small and you can have too many, you can have too little. And that's an interesting point in there.
Right. And there's two different directions you come at that from, right? So on one hand, OO programming is about defining types. It is a type system, right? When I pick up an accounting program, it should read like I'm doing accounting. It should have accounts and journals and transactions and debits and credits. I mean, it should be very clearly accounting language. You've built the domain language in OO so that you can solve the domain problems. So it's about types. And so if we ignore a lot of other things and just go to types, a lot of people make software that isn't very OO. And the reason is because of primitive obsession. So they do everything in lists and dictionaries and for loops and integers and floats and strings. And this is really, I think, the first place where the problem starts. You do want a lot of tiny classes, but they need to be tiny, meaningful classes. So if you look at a string, there are a whole bunch of things you can do with a string. There's substrings, adding uppercase, lowercasing, translating, putting it from one, whatever. Okay, are those the same things that you want to be able to do with the social security number if you're a US person, or an ID number, or a string of a GUID? Does it make sense to do those things? Well, no, it doesn't make sense to do those things. There's no sense at all in doing those things. But if you have a string, that's all part of the strings, that's what's on the tin, right? What can I do with a string? 1,000 things. Okay, what can I do with a GUID? Nothing. It should be immutable. So what do? Do you just pass strings around all the time? Well, no, you probably should have a GUID type for that, right? An age. An age must be a positive number. There's no sense in a human age being, greater than 200, because no human being has ever lived to 200 in our history that we know of. Okay, there are some records that are scriptural that may contradict that, but I think it's pretty reasonable to say most people don't make it to 150 or 120. So, an age is probably a positive number within a certain range. There are no 1,000-year-old people. So maybe there should be a type for that. So you get a bunch of little classes because you're dealing with dates and times and currencies. And so a proliferation of small types is one of the stages of object-oriented design. But if you only do that, you're still very, very primitive. You haven't reached the point that you have, responsible units that do things. You're just dealing with, I have mitochondria.
This resonates a lot with me because like most of my about 10 years experience in the software world has been in Rails apps. And I feel like there is Rails pushes you, I feel, or in most places I've worked at, Rails pushes you to have types that correspond to your DB tables. And that's all the types you have. Like you won't subtype money. Money will just be a big decimal or an integer of 4 places, whatever, right? And so based on that, it's really difficult to say, okay, I have meaningful objects because I have now an invoice object that has 1,000 things, can also be a credit note, can also serve as a transaction, can also, I feel like it's the paradigm, like the Rails paradigm is pushing me towards that. And so it's very difficult to wrangle it back to object orientation, right? And that's where I think those service objects we were discussing before come in that, okay, I'm going to save you from that because now I have a slice. It's a vertical slice. It knows too much, whatever. At least there is a boundary somewhere.
I think that mindset of having your active record or having your models in Rails, directly tied to databases is once you learn that you can have models that don't have to tie directly to the database is such like a mind-blowing thing that so many Rails developers, like I've been through that journey. It's like, oh, well, I can have objects that don't have to be backed by a database that suddenly free you up a lot. And I think figuring out how to take that behavior out of those the Rails database-backed models is like an epoch for developers when they get to that point, because all right, I've got so much, I can split this up into different bits, and you find that you start to gravitate towards only keeping database stuff in those models and kind of looking at other things that you can put in there, because like you say, with an invoice, it could have so many different things. It could have a credit note. Well, is that a separate object in itself that doesn't have to be backed by a database? Or it could have a payment, or I'm trying to think of something that doesn't have data to do with it, but is more like behavioral.
It could be like you could have a split for the invoice that needs to be sent, whereas it's different from the invoice that needs to be displayed, right?
Yeah. And that's one thing. So I'm quite reluctant to introduce state machines into my code at times, because sometimes I want like an unsent invoice and a sent invoice and a paid invoice, and to have them as different objects in my code rather than having an invoice that has a state of sent, unsent, paid, because they have their own behavior in those different environments. And so you can split them out into different objects, but there always seems to be a reluctance to kind of do that. It's like, oh no, but it's an invoice, it's sent, unsent, paid. But you can split them out into separate objects and have, but they might have one database table in your application, but they'll have their own behavior. Because can you pay an unsent invoice? I don't think so, because nobody's received it yet. So they each have their different behavior.
I think that's one of the things you see with domain-driven design, right? They have bounded contexts. So in this part of the business, an invoice means one thing, but in this part of the business, invoice is a slightly different thing. And over here, it's only really a verb. And over here, it's, these are the specific behaviors. And you can kind of fake that in C# with extension methods, but I do think that one of the problems with it is that when we tie it to an ORM, the ORM is going to limit you to the types they know how to serialize, right? And that's also, by the way, typically where OO falls apart in any system you look at. There's something at one of the crunchy edges, right? It's where we put it on the screen. Well, to put it on the screen, it's not your data object. It's a series of digits with a slash, right? Or string, or it's a calendar widget. So you end up having to take your objects apart to get them up onto the screen. And what happens if you print something on a report? Well, then you're pulling the currency, the numbers out of the currency and the formatting out of the currency to make it a string of digits on a report and into a PDF or wherever. And when you serialize it, you've got to lose the fact that it's a currency and it becomes either a string or an integer or something that serializes well. So at the edges is one of the places where purity breaks down. In the middle, it can properly be domain language and real OO objects.
I'm going to pick up on what you said there of when you have an ORM, you're kind of limited to what the ORM can serialize and deserialize. How often do you actually create new types that serialize and deserialize to a given ORM? Like I know in Ruby, in Rails, you can do that. I have created types that say, okay, this is who you store on the DB, and when I get it back, I want this to be a money object or a person or a name or whatever. How often does that happen to you?
I think I do a lot of it implicitly using some of like the underlying principles in Rails. Like in Rails, you call to JSON a lot, but not necessarily explicitly. It's done under the hood. And so that's kind of like serializing it one way. And you override that maybe on a plain old Ruby object so that you serialize the data in a way that you want to display over an API, HTTP API. But I don't think I've only ever seen articles and screencasts about people doing it into the database. It seems like a good idea, but I've never actually done it in practice.
I am an ORM avoider. I learned SQL. I think I was just done teething when I learned SQL. I like writing queries. I like writing queries that are efficient. But also, not everything we do is SQL either. Now, if I were working in Django or Rails for my living, I would probably use the ORM a lot more. Active record, I'm sure is a big time saver. And, none of our blessings ever come unmixed, right? Every blessing has some limitation attached to it. Well, yeah, okay, you're making a lot more money, but now you're never off the clock. So, whatever the situation is, it comes with a plus and a minus. And I think I've been lucky enough to avoid them. Sometimes, even go into something like Mongo, a NoSQL database sometimes is an aid. But ultimately, we're going to have to break things out and save their component pieces. And that's always obnoxious. So I tend not to do it with ORMs. I tend to avoid using ORMs if I can. The nice thing about writing analytic apps is you only have to deal with the data coming in and then display. You don't have to save it back out.
That's for sure. And yeah, I see what you mean, that ORMs can be a crutch in the sense that it helps you go faster, because now I don't have to think about SQL on top of my Ruby code, for sure. But it does limit what you can do with your objects, right? Because now I have a class that fundamentally does two things: some behavior and all the saving, deserializing, etc. Although it's hidden, it's there.
I do a lot of custom unpack into JSON kind of things. And there are classes built into Python to help you do that very easily. So data classes and tuples and various things.
There's also, I think it's a few years old, I think it's like from 2011, something called hexagonal architecture, which is this principle. I forget who the guy who wrote it, but there's an idea that like you have a repository object in between your business logic and or maybe it does contain business logic and your ORM class. So you can see it in Hanami, which is like an alternative web framework for Ruby. They very much use the repository pattern to kind of have that separation between the ORM and the business logics. And so it's an interesting thing that like in object-oriented design, we have these patterns that we can kind of lean on and use if we need to, if it's an appropriate scenario.
You brought me to a point that I wasn't expecting, but I'm gonna profit from. I feel like patterns are really tied to object-oriented design, in the sense that the rest of the paradigms, at least that I know of, don't have this ingrained sense of there are these patterns, they are recipes, you should go learn that book by heart, blah, 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 and we can discuss concepts with those names, right? How do you feel about patterns? Either the Gang of Four or any new patterns that have emerged?
So I was early in the patterns game. I was part of the group of people that Ralph Johnson would bring us together. We would have lunch every Thursday and go through patterns. He had invited me to audit his class on where they mined patterns out of frameworks. So I'm not the originist, but I'm a fairly early person in that game and have a lot of history there. The thing about patterns, yeah, they grew out of object-oriented frameworks. That's where we went to find them all. And patterns were nice in that you had to have 3 independent implementations. Something is not a pattern because it's something you figured out. You had to see 3 different authors in 3 different contexts have used that same technique to solve a problem. And then the job was to describe what was the problem they had, what did that solution look like, and where did that leave them? So again, things leave you with, limitations and advantages. And the goal was not to learn them all so that you can apply them all every chance you get. The goal was to read them so you'd understand how other people have solved problems. And of course, the code is not the pattern, right? And if you take a look, about 2/3 of the patterns looked exactly the same in code. It was the intention and the way they applied it that was slightly different. So you would learn how to solve problems the way other people did. And the idea was to learn how other people think and how they go about things. Somewhere along the line that turned into, if you write an OO program, you must compose it out of patterns and you must use as many as you can fit into the box, which was never the intent of OO or patterns.
Can I tell you how I see them as someone that came way later into them? Because I loved the idea and I read the book. I tried to read it with the Java edition. I struggled. Then I found one that explained them in Ruby. I struggled less because I know Ruby. And there is a website called refactoring.guru that has a catalog of them. And I go there regularly exactly because I have a problem. Hey, maybe there is a solution there that I can explore, right? But the way I really see a lot of use from them is as a vocabulary thing. Like, to do that, we should do some kind of observer pattern, or we should do a strategy pattern here because then we do I have a lot of value from patterns because they allow me to communicate ideas really easily.
I think it's interesting seeing people's journeys as they learn OO programming, that they figure out, I know how to create the nouns and verbs for this. And then, there's these patterns that exist. And all of a sudden, I don't know if somebody told me this term many years ago, they become architecture astronauts and they start over architecting it and say, I can use this pattern and this pattern. It's like, but you don't need to yet. And there's kind of a big, it's like a bell curve where they're throwing loads of patterns and loads of objects at it. And then they come down the other side once they learn the intention of it and the problem they're trying to solve, like Tim said. And so I've seen that journey so many times from so many different developers over the years, and it's remarkable that there's a pattern about patterns.
Yes, I think that's true. And it's the same, by the way, with list comprehensions. Somebody looks at the first list comprehension and think, oh my God, that's horrible. Who would ever use that? And then about 15 minutes later, the light goes on in the back of their head. It's like, actually, that's pretty elegant. And then the next day they write their first one. It's like, oh, this is cool. And then they start converting all their for loops into list comprehensions. And they suddenly realize you can do nested and tripling nested and quadrupling nested filtering, blah, blah, blah. And then the next Monday they wake up with a headache and a hangover. They say, what was I even thinking? This is so incredibly dumb. Let me go back and simplify. Everything has its place. But I think you first have to go a little overboard to find the limits and edges of a new idea. And people do this with, everything. And nowadays with AI, right? We don't know. There's this new idea space open to us, and we have to go chase down and find all the places where it doesn't apply so we can learn, what to do with it.
Yes, and it resonates a bit again. I'm bringing it a little bit back to object orientation in the sense that, again, when you create that object, that cell that needs to do X, you don't really know how it's gonna fit. You need to try it out. You need to give it too many responsibilities, then too few, and then to see that learning also. It's not only in your career with trying new concepts, it's also in the code you are applying, right? And in a discussion with Woody Zoyle, he said at some point, but that when they do ensemble programming, they will actually write out all the ideas that the ensemble has. So if there are 3 ideas thrown out, they will write them, the 3 of them, before deciding which one they are going to do, with this idea of, okay, let's explore all the options and let's try them on, right? And with the OP, probably there is the similar thing.
I think it's like, you make an interesting point about the object having too many responsibilities at the beginning. I was on a project with a colleague of mine, Sammy, who I think has been on this podcast before. And he was saying like, oh, how do you, like, I look at your pull requests and you have all these objects and like, it's all kind of neat and tidy and everything. Like, how do you do that? And it's like, well, you're not seeing how the sausage is made. Like, you're just seeing the end product. Like, the first bit of code I write won't have any objects because I don't know what they are yet. And then I can see how like the behavior, how it groups together. And so like I might take one object out of this bit of procedural code and go, okay, I now understand what this thing is, and then try and give it a name or try and figure out what the messages are I want to send to that. And kind of that's a whole process about object-oriented programming, object-oriented design is quite iterative in itself. Like, you solve the problem and then you abstract the problem. And it's sometimes something you don't see because in the books, you just see this is an object or this is a pattern and then it has this behavior. And so I think seeing how the sausage is made is important to learning the principles.
For that, I really like the 99 Bottles of Beer book from Sandy Metz. Like, it really taught me a lot about how to think about that sort of thing.
It's one of the advantages of the, now I'm also an old XP guy, so I'm big into all the XP practices and have been for years. One of the nice things about TDD, and I know people have different opinions because they've only ever seen it done badly or they've only, whatever. But the idea is that I'm stating, a simple requirement. So whatever else is true of this function, this thing must be true also. So if I give you the number 7, I should get back 42. What it does, how it does that, none of my business. Describing it from the outside first. So the way we tend to do this is you go inside and you make the test pass by whatever means, probably something horrible. Well, now you know that the test can fail and the test can pass. Good. That's important. So it's a good test. Now you look at it and you say, well, I don't like the way we're passing that test. So without breaking any of the passing tests that exist, can I make this pass in a way I like better? And then you go back and you look at the test and say, well, I don't like the way that it's phrasing the question. So can I rephrase the question and keep that working too, right? And then you look at the code and it's like, okay, now that I put this in the code, I realize 3 of the 9 functions on this class are all dealing with this one different topic area, and they're going to change independently of the rest of the functions in this class. Maybe I should start to consider whether I would have another class for that, but let's go a couple more tests before we decide. Let's look for a clear design signal before we make this change, even though it does seem, knee-jerk that we've got 2 classes pretending to be one. But that ties back to the point of anyhow, is to control complexity. The number of things you need to know at one time should be pretty small because our brains are small and we can quickly become overwhelmed. I don't know anybody who can cleanly read a 5,000 line function that has 12 parameters and an extra 45 variables and 17 levels of nesting at any given point, and just immediately understand it all. And people try to do that. They'll write something that complex before they start looking at it. And as they dive through it, it's like, oh my gosh, I don't know. This variable was touched here and there, and this if statement, that if statement. We can't break this down. It has to be exactly this big and exactly this ugly. OO is built to avoid that. You should be in a bounded space where you only have a few things in scope and you only have a thing you're working on that's very clear and precise. When it's not used to contain complexity, it's not helping people.
And yet I feel that some people will look at the output that is produced by using both TDD and OOP principles and will say, oh, way too many files. I don't know where to look at when I'm trying to find XYZ. In part because naming is complicated, in part because I want to absorb all the context before I make a change, right? How can we simplify that looking for stuff?
I think some of it is a mindset shift. So I've been on projects where people they're trying to figure out how everything works. and I equate it to when you drive a car. So when I drive a car and I want it to go forward, I put my foot on the accelerator and it goes forward. I don't care how the engine works. I don't care like the internals of that. And so some of that applies to, for me, my set of object-oriented programming. I just care about the thing that's in front of me. If I press the pedal, I go forward. And if I turn the steering wheel, I turn right or left. And I think that's some of it is like, do I need to know what's going on all the way down at the bottom right now? Or do I just need to know what's in front of me? Oh, that didn't work as well as that didn't do, you write a test around it and that didn't behave the way I expected it to. I wonder why. I'll go down a layer and look. And I mentioned it before, it's a little bit of trust that the object is named correctly and does what you want it to. And I think both of us coming from the TDD world, or all three of us coming from the TDD world, we might write the test first and go, what does this thing do? Like, is there a test already that does this? Or I might just write one to see like, oh, okay. Yeah, it goes forward when I press the pedal. Or I press this and it goes sideways. That's weird. And then to kind of dive into it.
Why did it go in reverse? Yeah. And then, as you dive in, you start to see things that it's almost like a table of contents, right? You have an outline at the top level. At the high level objects, I find the top of the system. I filled out this data. I hit OK. What happened? Well, it reached into the back end for front end, and here's the transaction. It's using these things, these services, or these objects, right? And so at this point, it's trying to send to the powertrain. I get down there, the powertrain, it depends on the state of the system, whether we happen to be in reverse or forward or neutral, right? Whether it will bother to provide. And it's like, oh, we're not moving because I'd never put it in drive or first. That would make a lot of sense. Now I have to come back to the top and revise my test to be more competent. But I think what Rob says is right. The objects are assumed to be competent unless they're proven not to be. And then the assurance on that proof is in the tests, right? So I know the thing is competent because it passes all of the tests so far. And so everything it's been asked to do, it does that correctly. So I just need to know where in the chain of things does it start to go wrong? Do things go pear-shaped or sideways? And then I could just go look at that part because the rest of the system works.
I'm just going to make a quick promise to the audience. I'm not paying people to say that TDD is something that you should try. It's just people come here and say it. I'm a big advocate of TDD, and I find that it comes up in a lot of my episodes without me saying it. So I just want to assure people I'm not pushing people towards saying it. But regarding the assuming that the objects are competent, you're assuming that because they are tested, right? How would you assume that if they are not tested? Like if you have a class that has 1,000 lines, 5,000 nested ifs, et cetera, that is not tested, how would you approach that to say, okay, now I can trust it?
Well, do 1 million people use it every day in production?
Fair enough.
If so, then whatever it's doing must be the right thing. And that's why the standard first step in legacy code is to wrap it in tests. And the tests are, we pass it the values, it gives back the values, because whatever it's doing is correct. So you literally are pasting its responses in as the expected response, because you know that 10 million people use it every day and are quite happy with it and have been using it for 15 years. So, that's the best proof is that it satisfies what the users need. And then if you can lock down what it actually does, then you can change it without breaking what 10 million users depend on every day.
It makes me think of Chesterton's fence. I don't know if I mangled
Yes.
that name, which just because it's a bit more obscure of a concept is basically if you see a fence in the middle of a field, you shouldn't say, oh, I can remove it. It's more, before I can remove it, I need to understand why it's there. And here it would be a bit of the same, right? Like adding the tests of it's doing this now. So I know that's right because people are not complaining. And now I can start to remove stuff or do things as long as the output doesn't change, right?
Yeah. So, if the system's never been fielded, then, and you don't have tests, then for all you know, it could be an exploit.
Sure. I do think that there is this drive in object orientation, or at least what I understood in object orientation of, I can model reality or I can model my domain. with objects, or that is part of quote unquote what I was sold. How closely can we actually try to model reality with objects?
I think pretty well. I think there's a lot of concepts when we come to writing object-oriented program or our systems that sometimes we rely too much on the physical things that we try and model, but you can model the unphysical things. You can model a transaction, which isn't a physical thing, or you can model a concept of a delivery maybe. And so I think you could talk to physicists, talk to mathematicians. They're out there trying to model the world in all these kind of ways, and they seem to have been fairly successful over the centuries.
But if it's gonna take me centuries to model my business, I'm kind of screwed.
So, you could have started with your accounting app saying, well, a ledger is a book made of pieces of paper. What is the chemical composition of paper? And you probably would never have gotten anywhere. I like to refer to that as, you are building the language in which you will solve problems. I think that's the easier way to think about it, which means that I don't need the ledger to be a book made of paper with blue lines on it. What I need is that the ledger is a collection of transactions that I can use to determine my current level of wealth or debt. So you're taking things, all models are wrong, some models are useful, and what you're aiming for is useful. So what is the essence of the ledger in as far as my accounting program is concerned for me to produce useful results? So, when people do the circle, square, rectangle thing, well, a square is a rectangle, therefore there must be inheritance, is incredibly naive, because it depends. Does your application need to treat a square as a rectangle? Is that commonality of meaning to your application? And does it fit the expectations? Does it help you provide a meaningful result? You don't model things because they are, or because they are true. You model things because in your model, they provide a useful abstraction and a good piece of vocabulary that you can use.
I like I had never made the vocabulary connection, and I like that very much. On top of I want it to be useful. I really like that vocabulary thing of, okay, it's how my app talks, right? It's how my program talks amongst itself and to the exterior world.
It's a really powerful thing as well when you're building an application and somebody's describing like the business context of it, to have a piece of paper and just start writing down all the nouns you hear them saying, because they're the concepts that are going to exist in your application, highly likely. And then it also gives you the shared vocabulary, not just amongst the people delivering the writing the product, but the people also associated with it. So then you can have a conversation with the different stakeholders about ledgers or whatever you need to talk about. And it's a really powerful thing to kind of just be noting in like those planning meetings. Oh, they said the word ledger. Oh, they said the word book or whatever, to kind of write that down and keep track of those things.
Yeah, but also, again, back to the don't be a ninny concept. I have never been walking down the street and tripped over a PDF formatter. I've never had one walk up to me and shake hands. So it's okay if there are things in your code and your model that are not existent in the real world, right? I could probably pull up any of my programs and show you 1,000 things that have never existed in the real world, but they exist in the model and they support the model, right? And that's why it's in layers at the top. It's types and components and modules, which, by the way, you need. How many of you, let me back this up and give it to you this way. I take this informal survey whenever I give a public talk, and I will ask people, what percentage of the source code of your company's product do you have internalized that you just know by heart? What do you think the answer is I get? I'm not asking you. I'm asking, what do you think the answer is they give?
I think people will be overly optimistic and say something like 70, 80%.
I was going to go completely the other way and say like 1%, which is interesting. Yeah.
So if they work in a small company, they may go as high as 30. In a large company, they tend to stay on the low side of 5%. So you actually don't know your product. You might know a microservice or two. You might know some set of files in a directory, but do you really know the product top to bottom? And they don't. Well, why? Well, you can survive with knowing an area if you don't leave that area, right? So if you've never been more than 5 miles from your birthplace, you know those 5 miles really well. You know every resident, you know every store, every restaurant, every cafe, you know where the potholes are. But what if, you move across the country every third month? You don't know any place all that well, but you know a lot about geography and the space and the way different people are and how they do things. Well, in your code base, most people only know about 5% or 10%. What happens when they have to wander out of their space? Will they see familiar words? Will they see familiar styles? Will they be able to browse and navigate? Maybe I don't need to know where Fleet Street runs because I live on St. Albans Road. And I know that if I go, up around the corner, if I get up to Cannon Gate, I know some things there, but I know how to get to Cannon Gate. But I may not know intimately all the places in between and all the possible routes. Well, think about that in your code base. How can you navigate and how well can you survive? What if, you cross the street and they speak Norwegian, and you cross the street again and it's Finnish, and you cross the street again and it's Mandarin?
I feel like I have a different answer here because I was brought up on those code bases where they speak Mandarin and they speak French and they speak English and they speak Spanish, and you go somewhere and it's a completely different paradigm. And so I kind of learned to, like, that's my comfort zone, kind of. So I wouldn't be that thrown off by, okay, I go to a new place in the code base and this one uses services and this one doesn't. And just like, okay, I can find my way in the weird places, right?
You can find the local patterns and recognize them.
I think a good pattern for that, talking about different languages, like if you go to an airport, like there's certain iconography or there's certain structure to the signs. There's like a standard there that allows you to kind of navigate your way around the airport. And so if you by using objects in a I've forgotten the word we've been using, but like in a trustful way, then you'll be able to follow the icons or like the structure of those signs that you've seen, regardless of the fact that you might not know the language or you might not understand the domain. Like there's certain things that you can pick up to kind of go, oh, I can kind of go this way. There's something I understand here.
Which I think goes to a different thesis, and Matthew Carlson and I are working on this to bring this idea out more. Defects in code arise from misunderstandings. If you understand where you are and what the context is and what the data flow is and what the behavior is, then you'll probably do things right. But when you misunderstand the local language, that you don't understand the functional structures, you don't understand perhaps how the data is used or why this is called that, then you're more likely to make a mistake that will turn into a defect, right? So it's all about clarity. And one of the ways we manage that is with bounded spaces, right? So if I'm inside the automobile transmission class, right, the powertrain class somewhere, if I don't understand that there's a gearing involved and that sometimes you do want to go backwards, I could make mistakes where cars are going forward and should not. I might reverse directions on people because I think it should go forward, not knowing it's situational. So the idea ultimately of OO was to create these great bounded contexts. And we see the same thing done with microservices and with other techniques these days. But if you were to drop back where everything was a monolithic app, for the most part, back into the 80s and 90s, I think you'd see that it was a pretty effective and almost the only local technology for really bounding contexts other than you do C++ modules and libraries, right? So, libraries and microservices and components, that's just the same idea. OO is just one of those, right? It's just a way of giving a local context with its own set of meanings and intentions that you can then use at a higher level. It's all composition and decomposition.
We're getting close to the end of the allotted time. I'm seeing now the time, and I hadn't realized. I do like to finish the episodes with a question that is similar for all the episodes, which is, if you were recommending a junior that wanted to learn more about OOP, what would you tell them?
So Miller Page Jones wrote a really nice book. The original title was What Every Programmer Should Know About Object-Oriented Programming. I think that a few years later, they retitled it to make it better for SEO or something, and it was some horrible name. But look for Miller Page Jones. If you can find the original book, maybe you can find how it was retitled. It's small enough, good enough, brings out all the important issues. He does a great job. If you can't get that, then the next choice is the 1,800-page tome written by Bertrand Meyer on object-oriented software construction.
Yes, I'm just curious about that book now. I'm going to have to look that up. I think mine would be, definitely from the Ruby world, it would be Practical Object-Oriented Design in Ruby, or sometimes called PUDA, by Sandy Metz, who was also a former Smalltalk developer. I recommend that to everybody. I think it's a fantastic book, fantastic concepts. It's so well written, and the fact that we still talk about it years later, I think it's a classic tome. I can't speak highly enough of it. And as a follow-up to that, any talk by Sandy Metz is fantastic as well.
Hear, hear.
Okay, I think this is a wrap. Thank you both very much. It was great discussing with you, and thank you very much.
Thank you, Pablo.